Imagine for a second that we could go back in time, back to that one crucial moment where our own lineage, the one that leads right to Homo sapiens, splits from our cousins.
You mean the Neanderthals and the Denisovans?
Exactly. Paleoanthropologists have been searching for that moment,
Yeah.
that last common ancestor, for generations. It's always been this huge puzzle with a massive piece missing right in the middle.
And that search just got a major breakthrough. We are talking about fossils that don't just estimate that split. They land almost perfectly inside the genetic window where it's all thought to have happened.
A time 750 years ago.
Right.
So that is our deep dive today. We are unpacking a brand new analysis of hominin fossils from Thomas Quarriite in Casablanca, Morocco, specifically a place called the Grotte of Hominidés.
And our source material for this is the Nature publication itself, which details decades of really methodical work by an international research team.
Our mission here is to really get into why this date, this incredibly precise date, and the anatomy of these fossils, why it all fundamentally anchors the history of the Homo sapiens lineage.
For you, the listener, this is really a shortcut to understanding where we come from. You know, that complicated branching family tree we share with all the other ancient hominins.
Okay, so let's unpack this. I think we have to start with the context, the location. When people hear Casablanca, they probably think of the movie.
Right, of course.
But for anyone who studies deep time, Thomas Quarriite is legendary. What makes this spot in Morocco so good for preservation?
It's a total paleontological gold mine. And it's all about its location right on the Atlantic coast.
Okay.
So you have these repeated sea level changes over hundreds of thousands of years, and that created this perfect storm of ancient shorelines, dunes, and especially caves.
And those caves are key.
They're absolutely key. The shifting environment meant you got rapid burial of sand and sediment, which basically created these ideal conditions for preserving, everything from stone tools to very delicate bones.
But I understand this wasn't some quick, lucky find.
Yeah.
This is the result of decades of work.
Oh, absolutely. The Moroccan-French program, Préhistoire de Casablanca, they've been working this area for over 30 years. I mean, meticulously.
30 years.
Yeah. They found layers with some of the oldest stone tools in northwestern Africa from 1.3 million years ago, all the way up to this new discovery in what they call the Grotte of Hominidés, the hominid cave.
So the cave itself is like a time capsule.
It's the perfect description. Carved by the sea and then sealed up by sediment.
So what exactly did they find inside this time capsule? What were the remains?
The assemblage is small, but it's incredibly informative. The main finds are a nearly complete adult mandible.
The lower jaw.
The lower jaw, right. Catalog number TIGH10717. Then there's a second adult half mandible, a child's jawbone, a few vertebrae, and some isolated teeth. So you get a look at different life stages.
And this is where the story gets a little chilling. This cave, it wasn't a home. It wasn't a settlement.
No, not at all. It was a pretty dangerous place. All the evidence points to it being a carnivore den.
How do we know that?
Well, for one, there are very few human-made stone tools. But there's a huge abundance of fossilized feces, coprolites. And then there's the state of the bones themselves.
I read about one of the hominin femurs. It had clear gnaw marks on it.
It did. The analysis is pretty clear. These individuals were brought into the cave, likely by a large predator, probably a hyena.
Wow.
It just paints this vivid picture, doesn't it? 773,000 years ago, this coast was a lethal place. You have hominins, panthers, rhinos, crocodiles, these giant hyenas, all interacting.
And not always in a friendly way.
Not at all. But it does mean the bones were deposited naturally, which weirdly is actually a good thing for dating them accurately.
Okay, let's move to that date because it's the most important number here. 773,000 years ago.
Yeah.
Getting that kind of precision on fossils this old it's usually impossible, right?
It's next to impossible. Usually the geological layers are a mess, or the dating methods have these huge error bars, like plus or minus 100,000 years.
So how did the Casablanca team nail it so precisely?
They used a technique called magnetostratigraphy. They basically latched onto a massive global event.
Which is?
The idea that the Earth's magnetic field flips every so often. North Pole becomes South Pole and vice versa.
Like a polarity reversal.
Exactly. And when that happens, tiny magnetic minerals in any new sediment, like mud or sand, they align themselves to the new magnetic field before it all hardens into rock. It's like a fossil compass.
I mean, it happens everywhere at once.
Everywhere. It's an unshakable global signal.
Yeah.
And they found the signal for the most recent major flip.
The big one.
The biggest one, yeah. It's called the Matiyama-Brunhes transition, or MBT. It's the last time the Earth's field flipped from reverse, that's the Matuyama phase, to the normal field we have today, the Brunhes. And we know that happened at 773,000 years ago.
Plus or minus just 4,000 years.
Yeah.
That margin of error it's tiny.
It's incredible for this time period. And to confirm it, they took 180 magnetostratigraphic samples.
Yeah, 180.
That level of resolution is just, it's unprecedented for a hominin site like this. They could literally see the sequence. The older layers had the old reverse polarity.
Hanodiyama.
Right. Then the layers with the fossils showed the flip happening, and the layers on top had the new normal polarity. The sediment was laid down so fast it basically caught the reversal in the act.
I saw they tried other dating methods, too.
They did, things like OSL and ESR, but those gave much younger, sort of inconsistent dates around 500,000 years, maybe because of things like uranium in the teeth messing with the readings.
So the magnetic data is the master clock. It overrides everything else.
It's the geological certainty. It anchors these hominins, without a doubt, to 773,000 years ago, right at the starting line for the modern human story.
So we know when they lived. Now for the big question, who were they? Anatomically, this is where you get into the high-tech stuff, right?
Yeah.
Micro-CT scans, geometric morphometrics.
Yep. This is where it gets really subtle. And what those tools revealed is a fascinating mosaic.
A patchwork.
A patchwork, exactly. A combination of very, very old features alongside newer, what we call derived traits that are closer to us and to Neanderthals. They're sitting right at an evolutionary crossroads.
Okay, let's break that down. Looking at that main jawbone, THI-GH10717, what are the archaic, the old traits that look like, say, Homo erectus?
The old parts are mostly the overall shape. It has a receding symphysis.
The chin area.
The part that would be the chin, yeah. It slopes backwards, so there's no real modern vertical chin.
Yeah.
And the main body of the jaw, the corpus, is really long, low, and narrow. Very robust.
I also saw mention of something they don't have, some internal ridges.
Yes, that's a key detail. On the inside of the jaw, it lacks something called the superior and inferior transverse torus. These are bony ridges that you see in classic Homo erectus to brace the jaw. The Casablanca jaw is smoother inside.
Which is more like us.
It's leaning in our direction, yes.
Okay, so if that's the archaic part, what are the derived traits? The newer features that link them to the Neanderthal and Homo sapiens line?
They're subtle, but they are critical. The jaw has a shallow mesenteric fossa, that's a little dip where the big chewing muscles attach, and a symmetrical mandibular notch. And those specific shapes are hallmarks that you find in both early age sapiens and Neanderthals.
So the way their jaw worked was changing.
It seems like the mechanics were evolving away from that older pattern.
Let's talk about the teeth. The dental evidence can be so revealing. I read about the enamel-dentine junction, the EDJ. Why look deep inside the tooth?
Because the surface of a tooth can be completely worn down, but the internal structure, that boundary between the enamel and the dentine, is protected, and its shape is genetically determined.
So it's a true signal.
It's a very reliable taxonomic signal. And the EDJ structure showed these hominins were distinct from Homo erectus and also, importantly, distinct from the European group, Homo antecessor.
And what was the crucial thing they did not see in those teeth?
They did not see the specific derived traits that later defined Neanderthals. The building blocks of the Neanderthal lineage just weren't there in this African population 773,000 years ago.
So they hadn't committed to that evolutionary path yet.
Exactly. They represent a group that's still, well, it's still full of potential.
And this is where we connect the two big pieces, the anatomy and the date. Why is that 773,000-year window so vital?
Because it's the perfect meeting of genetics and fossils. For years, genetic studies have estimated that the split between our lineage and the Neanderthal Denisovan one happens sometime between 765,000 and 550,000 years ago.
So these Casablanca fossils, dated right at the oldest edge of that window, are basically the earliest possible candidates for a common ancestor.
Precisely. They are right now the strongest candidates we have for an African population sitting right near the root of that shared ancestry.
Which reinforces a deep African origin for our species.
It does. It suggests the split was happening closer 800,000 years ago, not 550,000.
Okay, so this forces a really important comparison. You have these hominins in North Africa. What about across the Mediterranean in Spain? You have Homo antecessor from Atapuerca from around the same time. How do they stack up?
Well, they do share some features, which suggests there was probably some contact between North Africa and Southern Europe back then.
But the differences are what really matter here.
The differences are what matter for tracing our direct line, yes. The researchers are very clear that the Casablanca hominins are already clearly separated from the Spanish group.
What was Homo antecessor doing differently? What evolutionary path was it on?
The key thing is that the antecessor fossils from Spain were already showing traits that are derived toward the Neanderthal morphology.
Ah, so they were already starting down that specific European path.
Yes, you can see the very early signs of the facial structure and skull shape that would, hundreds of thousands of years later, become classic Neanderthal features. Moroccan fossils don't have those markers.
Which makes them a much better candidate for our direct ancestor.
A much more appropriate basal population, yes.
Okay.
One that could go on to evolve into Homo sapiens.
That's a huge shift in thinking. It implies the African lineage stayed more flexible, while the European one was already starting to specialize.
It really puts Northwest Africa, the Maghreb region, not on the sidelines of our evolution, but potentially right at the center of it.
Which brings us to the Sahara. For so long, we pictured it as this massive permanent barrier separating North Africa from the east and south.
And we now know that just isn't true. The geological and paleontological evidence, finding the same types of animals in Northwest Africa and East Africa, proves it wasn't a wall.
It was dynamic. It opened and closed.
Exactly. You had these green Sahara periods driven by monsoons where the desert bloomed into savanna and grassland. These were ecological corridors.
Allowing for movement. Gene flow?
Gene flow, population movements, all of it. It means the ancestral population that led to us wasn't necessarily isolated in one tiny corner of the continent, like the Rift Valley.
So wait, the concept of an African root just got a lot bigger.
It totally challenges the idea of a single centralized cradle of humanity. It suggests a vast, interconnected Pan-African network, and Casablanca just became a major hub on that map.
Okay, so let's bring this all together for you, the listener. What have we really learned today? We have a hominin population in Africa securely dated to 773,000 years ago.
And they are sitting right at that evolutionary fork in the road.
With this unique mosaic of features, part ancient, part modern, that defines a lineage still distinct from the one in Europe that was already on its way to becoming Neanderthal.
These fossils give us the best morphological clues we've ever had for what that last common ancestor of all three groups, sapiens, Neanderthals, and Denisovans, might have looked like.
By aligning the fossil record so perfectly with the genetic estimates, this just doubles down on the deep African origin of our species.
It really does.
Which leaves us with a final, really provocative thought. If the Maghreb region wasn't a fringe area, but a central player, and it was connected to the rest of Africa through these green corridors, what does that imply about the sheer scale of our evolution?
It means we have to completely rethink the ancestral landscape. If Northwest Africa was a pivotal center, what other distinct Homo populations might be out there waiting to be found further south? In West Africa, in the Congo Basin, all from the same critical time period.
So the cradle of humanity might not have been a single cradle at all.
It might have been a vast, interwoven African superhighway, and we've only just started mapping the stops.